I am Professor Guru Rao. I am an honorary professor at the Indian Institute of Science. Earlier, I worked as the professor at the solid state structural chemistry department, and in addition I was also the dean of science faculty before retirement. At this particular moment, my interests are in structure determination, and in particular ask questions like what happens to an atom when it becomes a part of a molecule, and what happens to a molecule when it becomes a part inside the crystal, how the molecules are arranged, and what are the forces that hold them together in terms of the energetics that are involved, and also in terms of the directionalities which come up in a crystalline medium. The course, which is entitled the solid state, the symmetry and structure in the solid state, essentially concentrates on the solid state aspects, that is to look into the state of matter which is in the form of a solid, where the requirement of periodicity becomes a very crucial issue when we talk about crystalline solids. So, the course directs itself towards the crystalline solids, and in particular it looks at all properties that get associated when periodicity is getting introduced into a crystalline solid. The way we plan this course would be to first look at the concepts of symmetry, because symmetry is something which controls how the atoms and molecules and eventually the unit cells are arranged inside the crystal lattice. So, the basis of symmetry will be covered in the first few lectures, with an emphasis of looking at point groups and space groups, not from the group theoretical point of view, but from the point of view of understanding what solid state structures are. So, essentially we will look into structures of materials and so on in the long run, but we get a basic idea of what are point groups, what are space groups initially, and once we have that information, we will see how these concepts develop into objects which will have by itself a certain amount of symmetry, and how those objects which do not have symmetry also incorporate symmetry in order to go into the solid state dimension. And this will be the first few lectures. And once we have this information that is available to us, we will look into the possibility of how to explore these in realistic situations. And there we bring in the concept of X-ray diffraction, and we will look at the X-ray diffraction basics, how X-ray diffraction helps us in understanding the periodicity and hence the determination of the point groups and space groups. We will go into the discussion of X-ray diffraction patterns, the origin of X-ray diffraction pattern, the reason how the X-ray diffraction pattern is responsible for giving us the geometry of the diffraction condition, and followed by the fact that the powder diffraction, where we look at powder materials, and single crystal diffraction, where we look at single crystalline products. In both these cases, how the geometry comes up first as a first information, and we then derive the Bragg's equation, Bragg's law and so on, which is routine. And then we look at the various aspects of reciprocal lattice space, the interaction between the direct space and the reciprocal lattice space, and how we go from one to the other, the conversions and so on. Followed by the fact that we now see that the intensities which come in these experimental patterns are the ones which tell us about the electron density distribution in the given material, which in fact is our aim. Our aim is eventually to get an understanding of the structure of molecules, structures of atoms inside the molecules, and the structure of molecules in the crystalline lattice. We will also look into the fact that how these atoms come close to each other, what are the various ways in which we understand the bonding features and so on in the latter part of the course. So, the course now has reached a stage where we will have the X-ray diffraction basics completely understood, reciprocal lattice concepts, and how we can do X-ray diffraction experiments in order to get information about the lattice dimensions and also eventually get to the structure part. This brings up the issue of the structure determination protocols, and we will talk about how we determine these structure determination protocols in terms of methodologies which have developed over the years. And once we have this information, we will look into the possibility of solving realistic structures. At this stage, we will also introduce the concept of least squares refinement, which is employed in order to get to the final structure. since we always generate a starting model from all these procedures we have understood so far, the determination of the structure gets finalized when once we refine the structure to the best possible values. And then we look at the features of the geometry, the way in which the atoms are arranged and so on, and get to the details of the geometrical arrangements, the interatomic and interactions and so on, which will tell us about the supramolecular assembly of these molecules and the corresponding property which becomes a consequence of the arrangement of these molecules inside the crystal lattice. And at that particular stage, we will also look at the possibility of applications in pharmaceutical and materials industry, which in fact forms the basis for understanding any material in terms of its structure property relationships, which eventually brings the curtain down on this particular course. I think this in general is an introduction to the course Symmetry and Structure in the Solid State. Thank you.